Alright, let's see what we can do to help you understand Newton's third law of motion. Let's start off today with looking at some definitions. We'll talk about the third law, and then we'll take a look at some examples. In order to help us fully understand Newton's third law, it's important that we have some definitions clearly in mind. First of all, we want to define what action forces are. Action forces are simply 1/2 of any interaction. Now, to understand what an interaction is, I want you to think about trying to clap your hands. Can you do so without actually making a connection to your other hand? Or how about sitting on a chair? Can you do so without your behind actually touching the chair, and say you're actually sitting on the chair? Now, we're talking about things on the macro scale. That means big things we can see. We're not talking about on the atomic level where we've got electron repulsion. So I want you to think of things on the macro scale. Can you push if there's nothing to push against? Well, of course not. So an interaction is simply when two objects are exerting force on each other. And the reaction is simply the other half of your interaction. So, like your left hand touching your right hand touching your left. There you have your action forces, your reaction forces, and when this happens, you have an interaction. Now, Newton's third law says that for every action, there is an equal and opposite reaction. That's it. And this is just simply describing what happens anytime you have an interaction. So, for example, if I push on a wall, what is happening? Well, if I'm pushing on the wall is pushing back on me. If I take a bat and hit a ball with it, not only is the bat hitting the ball is hitting the bat. Now, here's really important. These are equal and opposite. So, let's take a look at another idea. Let's say that we have a car traveling along, and this car encounters a tiny little bug. When the car hits the bug hits the car. We have here an interaction. According to Newton's third law, the force with which the car hits the bug is going to be equal to the force with which the bug hits the car. Now that may seem a little strange because certainly you know the effect on the bug is much, much greater than the effect on the car. But remember, let's tie that back to Newton's second law, where we were talking about masses and accelerations. If the forces are equal and opposite, the effect on the massive car is going to be very small, whereas the effect on the very tiny bug is going to be very big. So you can see that we can have equal and opposite forces where the reactions or the effects of it are very different. So let's talk about some examples. Alright, so we gave one example. A man pushes on a wall. What would be the reaction half? That's right, the wall pushes on the man. How about if we have a man stands on the earth pulls on a man? Well, Newton's third law says that if the earth is pulling on a man, the man is also pulling on the earth. Action, reaction. Another example could be a hand hitting a desk. The desk is therefore hitting the hand. Think of your own action-reaction pairs, and remember there are some key and important things. All forces come in pairs. You cannot have a solo force. All forces come in pairs. Second idea, these forces in an interaction are always equal and opposite. Now these concepts will come very much in handy in our next unit when we're talking about momentum and energy. Hope this helped. Have a good day.